at our Group 10 review for the second exam. Okay, so I opened it up. Number 1 is true because we're all going to participate. Okay, so I missed this on the homework quiz. I had to really go back and learn this. But number 2, given a 90% confident level for heart rate, which of the following is the best interpretation? 90% of all people have a heart rate between 45 and 105. We are 90% confident that the true mean heart rate is between 45 and 105. And then the other two say chance and chance. So he said, if it ever says chance, you know that's not right. It always has to say confident. And he said, what were the 2 key words is confident and true mean. So if you put confident and true mean in there with the percentage and then that's what we're looking for. So even if it has something where like 95% confident that 95% of all the confidences that we would have the true mean between this, that one still counts. That's the only other one. And it sounds weird, but he said that's the only other one. It has to say confident and true mean. And if you can know that, then you'll get it right.
So it's the second one.
So the second one. So we got the little researchers here. Hey, Min, did you do the homework?
Yeah.
Okay. Did you do the homework, Lauren?
What?
Did you do the homework?
Just a little bit. I didn't really finish it.
There is no answer, so I was just wondering.
Yeah, I didn't finish the whole thing.
I sat here and tried to do it all. Then I was like, well, how am I supposed to check my answers? And it says, ask your group and compare your answers. And it's like, oh, I don't want to know right now if I did it right. Okay, so we're on number 3.
Okay.
The second one was, I feel like strongly it's number 2. It's the second one of the second question.
When does the exam close?
Saturday.
Saturday. Okay.
Yeah, we have some time. This is a lot of it's determining. So we have a difference of means. They want to find out, and if they have a QQ plot to find out that they're normal. And it says random sample, so you have to look for those keywords. And it says, since it doesn't say anything about a known standard deviation, we know it's going to be T or F or the ANOVA or whatever. So the only thing we really need for that is say, yes, the distribution means that each sample is normal since the data have been determined to be normal. Essentially, that's it. It's not, we need a larger thing. We don't need, because it's normal distribution. And we don't need to worry about the central limit.
Yeah.
Because you still have to have a larger, anyways.
Okay.
That one I did get right on the quiz. Well, he did a sample if you watched it, and it was on there. Okay, number 4. Of the 4 types of confident intervals listed below, which one is appropriate for this experiment? So we know it's not the second or the fourth because they're identical.
Oh, when it's known or unknown.
Oh, it's not identical. Either way, we're not looking for confident interval for you when we go back up here. Of the 4 types of confident intervals listed below, which one is appropriate for this experiment? So we got to go back up to the top. Information. Researchers, Mississippi, want to determine reaction times between males and females to participate. They randomly selected, and that's all the information we have. So we don't know the interval. I'm going to say it's the third one because we do have independent samples and we don't know the mean. And we are going to find the mean that is the difference between.
I think it's the third one too. Confidence interval for the difference of means using independent samples.
Yep.
Of the-
Okay.
do you guys agree?
Min's mic is muted. All right, well, if you disagree, speak up. Okay, number 5. A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of random sample of 30 customers. She has a 95% confident interval for the mean savings account balance of the customers, and it's found to be between those numbers. Which of the following would produce a confident interval with a smaller margin of error than this 95% confident interval? A smaller margin of error. Compute a 99.
Would it?
Wouldn't that widen it?
Yeah.
It makes it smaller on the type 1 error. That
Would it be the last one?
would make a wider margin. So it would need to be less than 95. Make a smaller margin. So I'm going to say none of these answers.
Which of the following savings account? The first one's wrong, right? Because wouldn't it?
Yeah, because we need at least 30.
Yeah. And then compute 99%.
That would make it wider.
I think it's none.
Wouldn't it? I'm busy, honey. Sorry. Okay. Anybody else agree or disagree? Let us know. We'll find out, I guess, when it's over.
So what's the answer?
We think
Which
it's
one are you saying?
none of these answers for number 5.
Yeah, which one for number 5?
The none of these answers.
Do you agree or do you think?
I think
I can't really hear. People's mics are cutting in and out, so I'm having a hard time
Sorry.
keeping up.
It's probably mine.
Is it me too? Can you hear me fine or no? Do I cut out?
Yeah, it's you and Sam.
Oh.
Yeah.
Oh, darn.
When's is
Sorry.
fine. Cinnamons.
Okay. What about if I bring this over and I do?
I can hear everyone fine.
Okay. Well, what do you guys think about 5? I'll go like this and put my thing over here. And let me see if
I'm
I
not
can-
entirely sure, but I was thinking maybe the last one.
Wouldn't more make it? Oh, wait. Maybe yeah. Which of the following would produce a confidence interval with a smaller margin of error? Maybe it is the last one because the more you have.
I don't think so. I'm gonna put this up. I think that it is, but I don't know. I'm probably wrong. Is the statistics?
Let's come back to it.
Let's come back to it. Here's my little. Okay, so let's go down to factory workers. And so we know that they have a standard deviation, so we're going to do a z-score. And they have a sample mean, and they have a confidence level. And so we're going to put our answers in and determine the margin of error for this confident interval. Okay, so this one, I think that we have to use that margin equals, I started making a little paper because you can find that one sheet. I started writing down the formulas that I need to remember. So we need the margin of error is m equals z times the standard deviation over the square root of n. And then we'll add it and subtract it from the standard deviation. Okay, so we have, what do we have here? We have a mean of the square root of 4 divided by hold on.
Would it be 1.96?
That's what I got.
But then you need to add it and subtract it from the 1,000 so that you can get an upper bound and a lower bound, right?
Oh, but 1.96.
Oh, wait. Input your answers for the margin of error. So 1.1. Okay. And then, so our upper bound and wouldn't that be like whatever it is? Hold on, I need my calculator. I don't know where it is. Like 101, like 101.96, and then the other one be .998.04. So our lower bound would be 998.04. Do you agree with that, Min?
How do you find the mean? Or the mean is 1,000, right?
Yeah, the mean is up there, so it's right there. I can't really highlight it, but it's right there. And so we took that and we subtract it. Get this. Then our upper bound would be 1,000 plus 1.96. So it'd be 101. I don't know why I just did that on the calculator. That was really easy.
001.96.
Does that make sense?
Yeah.
Okay.
What was 7? It was 99.
So 7 is 998.04.
0.04. Okay, and then the upper bound is okay.
Okay, so then we have to access the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times. So we're trying to find the number. And the means of the weighing is computed. Suppose the scale readings are normally distributed with unknown mu and standard deviation of 0.01. How large should the n be so that there's a 95% confident interval where the mu has a margin error of? Okay, we have this. To find the sample size, you do n equals z times standard deviation over the margin of error, and then you square that whole thing. So we're going to put in n equals, so the 95 level confidence error, that would be 1.96, right?
Yes.
And then we're going to times it by 0.01. And then we're going to divide it by the margin of error, which we said was 0.123 and a 1. And then we're going to take, so you get 196, and now we're going to square it. So 38,100. So I'm going to type it in here. Can you guys see my screen?
No.
Oh, darn. I thought it was helpful.
So how do you do this again? Question 9.
Okay, so let me clean it up. Okay, what about now?
Yeah.
My pen work. So I did n equals, and I did z times standard of error divided by the margin, and then I squared the whole thing. Okay, so I did n. So n equals, oh, it's going to be silly now. Wonder I can go back and change it. Okay, so I did the z times the standard of deviation divided by the margin of error, and then squared that whole thing. Can you see that?
Yeah.
Yeah.
So I plugged in that 1.9, gosh, 1.96. And then I plugged in whatever that is, and then the margin of error was 0.001. So I can't remember what that one is, 0.01.
Standard deviation is 0.0.
And then squared the, and then times the whole thing.
Oh crap. Z is
So
Okay,
tell me if
I
we-
got it.
96
Did you get it?
Yep.
Okay.
0.01 divided by 0.0001 equals squared. Yeah, I got it.
Okay. So let's go to 10. Okay, the mean area U of several thousand apartments in a new development is advertised to be 1,200 square feet. The tenant group thinks that they're actually smaller. They hire an engineer and measure, and so we just need to decide which hypothesis works. Is so equals, they think that's smaller, right?
Would it be the last one?
Yeah,
I think it's the last one.
I think so too.
Yeah.
Okay, so 11. In a statistical test hypothesis, we say we read up with the level of significant alpha if the P is low, reject the null. Do you agree with that?
Yeah.
Okay, so 12, a group of statistics students want to determine if students in some apartment buildings get better grades than other students, so they randomly select from the different apartments. Data for each apartment building are bell-shaped, no outliers, and the sample variances are nearly equal. Can you use the ANOVA hypothesis to test the answer to the question?
I think that there's enough data.
15 from 4 of them. So we have 4 groups. So yeah, they're bell-shaped. There's no, and sample variances are nearly equal. I say that one.
Me too.
Yeah, that one.
Okay. Medical researchers is working on a new treatment for a certain type of cancer. The survival rate is 2 years. They did a test. They decided it was 4.5 years. Even though the sample is small, the results is statistically significant at 0.05. So consequently, she rejects the null hypothesis. In a future study, it's determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The research has now committed a type 1 error, right? Because they rejected, but it was really true. I watched the thing today, and he was basically said, you reject it, but unfortunately it was true, and you should not have rejected it. That's that small percentage that you might actually throw something out that was good. So 14, if the level of alpha is made very small, thereby making the probability of type 1 very small, what happens to the probability of committing a type 2 error? This one, and it's because it's a teeter-totter thing. You agree with that?
Yeah, by reducing the probability.
Okay. 15, nicotine content in cigarettes of certain brand is normally distributed mean of the standard deviation the brand advertises. Basically, we're just trying to, is the evidence that mean nicotine content is actually higher than advertised? To this, the test hypothesis is that it's, the mu is, okay, wait. To answer this test, okay, at the 0.5 level of significance, you should
wouldn't it be reject the hypothesis? I don't know.
okay, hold on. Nicotine actually, the mean is greater than
The
one.
last.
Okay, so we would reject, I think it's reject the hypothesis, like this one,
Yeah.
or reject the null.
Mm-hmm.
Okay, 16, you would like, you look at the mean number of hours worked for wages per week, and male students and female students would like a random sample of 100. If those means are different, what is the correct statistical procedure? Males and females.
Different.
I would say independent T,
That's what I
right?
was gonna say, independent, because they're all different.
They're all different. We don't have a mean, so,
Okay.
I mean, a standard deviation. Educator is interested in, so brother, sister, that's kind of important right there. Next, other siblings is a dependent, sister's academic, brother's academic, or dependent sampling, you selected a brother. So as you compare his academics to his sister, you must include the sister in your study. Do you agree with that one, last one?
Yeah. Must include, yes.
Okay, use the following information to answer the next 4 questions. Oh gosh, I hate doing these.
I know.
I just hate bringing it up. The researcher would like to construct a 95% confident interval for the mean to dissolve carbon level fields. Of the 4 types of confident intervals listed below, which is appropriate for this situation? Confident interval. Let's see, how many are we doing? Okay.
Would it be the first one?
Do we know the mean or the standard deviation? I think, what about third?
Confidence interval for mean.
It's not dependent.
Is it when it's known or unknown?
Okay, the only time oh wait, confident interval for when, you're right. I read that wrong. So it should be unknown. So that one?
First one. Okay.
Yeah.
Yeah. Good save there, Lauren. Okay, which of the following is 95% interval for this analyst? Input your answers and margin there. All right, I guess I gotta transfer all that stuff over.
So
All right, let me open this up. What am I looking for?
dissolved.
I hate this. Okay, so we're looking at a 1 sample t-test, right?
Mm-hmm.
Okay, so did you guys get that? 11.168, 15.217. Over here. Put it away. Get rid of that. Okay, so the margin of error for this confident interval. Okay, this is that one where we take the 15.217 and we subtract the 11.
Mm-hmm.
So 4.049.
Mm-hmm.
Is that what you got, Min?
Yeah.
I hope I did that right. Okay, input the lower bound, which would be, okay, and then input the upper bound.
The upper bound is the 15.217.
Yeah. And then we get to open a new one. Numbers. Okay, let's figure out which one we're going to open them. The data are recorded. We want to know the difference. Okay, so we have group 1 in Los Angeles. And it's over there. And we have, so we want to know what's the best one. The true difference of means. So it sounds like we're finding the interval for a mean of differences using not dependent, but independent.
Mm-hmm.
You agree with that?
Yes.
So 22, confident, okay. calculate the 95% confident interval for the true difference of mean listing between LA and New York. And then create your bounds. Okay. Let me pull them over. Okay. So, what did you guys get? What am I looking for? The lower bound. Okay, so a negative 423.238.
Yeah.
Okay. I just don't know. Sometimes I worry that I'm not cutting and pasting correctly. And so negative 423.238. And the upper bound of 5417.336. Okay, for the next 4 questions, we're going to do some exercising rats for their bone density.
Wait, what did you get for 24?
So, oops, sorry, let me get it to scroll back up. So 24 is that, oh, that's, yeah, 5417.336. Did you guys, what do you have?
Hold on, let me.
Because maybe I did it wrong, but I'm sure I probably cut and pasted. I hate doing this.
547336.
Yeah, never mind. I typed it in.
Okay.
Sorry.
No, you're fine. Researchers like to determine the mean levels of the bone density 0. What is the correct hypothesis? We got 3 groups. I think ANOVA. That's my guess, because it's got 3.
Yeah.
Okay, so now we gotta go do the rats. Here, little rats. Okay. All right, so calculate this. Now this one's the F score, right? Point. What do you think about it? Did you guys get that?
Get what?
Get
So
what?
the F value.
Oh, that's what I got.
Okay. And then the P value.
Maybe
The
0.002.
okay. And 28, which of the following tests express the conclusion of this test using the significant alpha of 0.05? Well, it's smaller than 0.05, so there is sufficient evidence to conclude that no, if it's not all of them, it can only say something's not right. What about this one?
That's the one I think. Yeah.
Yeah, okay. Use the following information to answer the next 4 questions. We got some plane tickets, buy them in advance, 14 days and 90 days. And we perform a hypothesis test. It is 0.10. So we have 2 of them and we don't know anything, but this is the one that was similar, that's been kind of constantly similar. I think this is dependent because they're comparing still the same cities.
Okay.
So the same city is being compared on 14 days and 90 days when I look at the, so I think this one is the dependent one. And if that's so, then we need to go to the pair sample test and calculate. Oops, sorry. Stop doing that. Because it looks like it's the exact same airports that, and they just, the only thing that changed was the day and time. So. Okay, what about
1.685.
yeah? Okay. Our p-value would be. Wait, let me make sure I set this thing right. This one not equal to.
Would it be 0.06?
Oh, it's just determined not equal. Okay. So 0. So I put 0.0. Yeah, 96.
The following best expresses the conclusion of this test. Use a level of significance of alpha equals 0.10.
Well, there's sufficient evidence to conclude there is a difference in the mean cost of tickets purchased 14 days compared to 90 days. I'm going to say this one. Let me keep looking. No, insufficient. There's no difference. No. Okay, that's my final answer.
Okay.
You guys agree?
There is sufficient evidence to conclude that there is a difference in the mean.
Yeah.
Yeah.
Okay.
Okay. Let's turn it on and see what we get.
Oh, wait. I don't have one answered. Which one is that?
Oh, we didn't do that. We didn't go back.
I just turned it in and we missed one.
Which one?
Well, I missed one. Let me see
Okay.
which one.
What did you guys for 11?
What was number 4?
Oh, 19. Number 4. 19 we got wrong. Let me look for number 4. Number 4 is, hold on, scrolling up. Number 4 is confidence interval for the difference of means using independent samples.
What's number
Okay.
11?
Number 5?
Number 11?
11 is the p-value is less than alpha.
We missed 19.
Number 18 is confidence interval for mean when standard deviation is unknown. And then for number 5, I put let me see.
Which one did you get wrong?
I think 19. But for 5, I got obtain the balances of 90 bank customers rather than 30. I think I might have typed 19 wrong though.
What did you put?
Okay, so you did get Octane balances of 90 bank customers and it was
Yes.
right?
Yes, for 5. I think it's because the more you have, like, as the sample gets bigger, the less margin of error.
That's probably true. Okay. We'll have to go back. Obviously, I don't understand the concept as well as I thought I did. Okay, so 19. So what did you type in?
4.049.
Okay, let me look at it slowly, thinking about moving on there. Let's just go there.
Do you guys need any more?
Well, let me get over there. My thing is going slow suddenly. Okay, so no, I just passed it. Okay, so I did 4.049. Was that what you did?
Mm-hmm.
Okay, so how do we fix that one?
It's weird that we got that wrong.
Like, how do you? Oh wait, well, I mean, I guess we could test it and see if we. Terminate margin error. What was our margin?
I actually have to go. Someone's picking me
Okay.
up in 15 minutes. So,
Okay.
yeah, I'm just gonna leave mine just this way, and then I'll probably look at it on my own and figure
Okay, sounds good.
All right. Thank you, guys.
Bye.
See you later. Good luck on your test.
The test, you
I
guys.
will try to see you guys.
Okay.
I'm gonna do my very best to get online and find a quiet room in Texas. So I'll
Okay.
let you know.
Sounds good. Thank you. Bye.
Okay, see ya.
Bye.
I have no idea. Oh, you know why? Because we got to divide it by 2. I mean, that's the difference between those numbers, but then we need to divide by 2. Find what the middle of that is. That's what we're doing wrong. We have to take the high from the low and divide by 2. So if I do that, I get 2.025. All right. I bet that's what it is. Okay, I'm going to turn mine in and go see what I got.
I already turned mine in. We still got it wrong. Or one of them is wrong.
Submit it.
The 19's right.
Oh, darn. What did I just get wrong? I just saw 0. Okay, I got 100.
What did you put for 32?